this certificate in hand, it could change your career. This is your first step towards becoming a certified Lean Six Sigma Green or even Black Belt professional. And it starts right here, right now, with zero cost with this Lean Six Sigma Yellow Belt training. No sign up fees, no gimmicks, just pure value. You'll find all the resources linked as we go. So stay with me, take notes, and unlock your professional edge.
So now let's dig in. What is Six Sigma? Six Sigma is a statistical approach of solving a problem where we try to reduce the number of defects to 3.4 parts per million opportunities. So this statement says that Six Sigma is a statistical tool of improvement. Yes, by the name itself, Six Sigma correlates each action based on the data and tries to improve the problem based on data and facts. You will see in the Six Sigma course that they use many statistical tools, Excel and Minitab, to perform analysis or say hypothesis stage or the design of experiments part, etc. And the Six Sigma operates in level of reducing the defects to the level of 3.4 parts per million opportunities. That means for every million products or service delivered, produced or run, the Six Sigma or the Lean Six Sigma adopted process will give only around 3.4 defects. That's literally a no defect approach. And one thing to understand is practically we cannot avoid eliminating defects to 0% by adopting any improvement strategy, but we can reduce down to the level where we can say the product or service is literally defect free. Then another definition of Six Sigma may be Six Sigma is a continuous improvement process. Yes, Six Sigma operates in a DMAIC cycle or define, measure, analyze, improve and control for the existing business and processes that needs improvement, and DMADV approach for the new businesses or processes. So after control phase, we again roll the cycle to make the further improvements in other processes. Both DMADV and DMAIC work are the continuous improvement cycles. Now let's check the another definition. Six Sigma is a holistic improvement philosophy for the overall growth of the organization. So thumbs up for this one too. Six Sigma works in overall improvement philosophy, taking well care of all the stakeholders and Six Sigma belts, namely the Six Sigma white, yellow, green, black and master black belts in the increasing order of the training and complexity and all other stakeholders. We form a goal statement, problem statement and problem objective of improvement in any Six Sigma project. So we work with the approach of improvement in any process or services when we adopt Six Sigma or Lean Six Sigma. So let us form our own definition of Six Sigma then. Six Sigma is a statistical and holistic approach of problem solving operating in the continuous improvement cycle. So these definitions look quite simple and effective. With a rich history of development and use in various organizations, ranging from the Motorola to General Electric to Allied Signal and all, we now have a time-tested method of improving the process that most of the Fortune 500 companies still use in their business operation. And with the inclusion of the lean tools in Six Sigma, we are now able to remove the non-value added steps from any processes or eliminate the waste and improve the customer compliance along with the reduction of the cost. We now have enough tools to fight battles of innovations and improvements with Lean and Six Sigma. Do you know that in the US alone, those with at least one level of Six Sigma training make an average of 17,762 per month, more than those who have not received any Six Sigma training. The national average of Six Sigma black belts would be around 108,000. At a higher level of certification or master black belt, the average is 57,000 more than that. The increasing level of the Six Sigma position is depicted through the professional belts. There are 5 types of belts: white, yellow, green, black and master black belts. And the average salary of the individuals keeps on increasing with the professional growth and the level of Six Sigma expertise. More on the belts later. So I've taken this data from the ASQ, American Society of Quality, which is an authentic and a global leader in quality. These are not just some made up figures. I encourage you to verify it at authentic job search site like indeed.com. But do not get confused Six Sigma for good income job only. Many students get confused when it comes to the distinction between these two improvement cycles. So in this lecture, let us see what are the differences between them. The differences between the DMAIC cycle and the differences between the DMADV cycle. DMAIC is used in those conditions where the products and the process already exist and we want to focus on improving the quality of the products or improving the customer's demand and satisfaction. That means we are basically focusing on improving the product, system or any business which already exists in the DMAIC. DMADV is basically used in those conditions where there is no existing products or services. DMADV may not work well with the existing products or services. So if you already have the existing business and services, DMADV might not be your choice. DMADV is used when the product or process improvement project simply fails with other improvement philosophies like DMAIC. And sometimes the whole system or the process may have to be redesigned so that a marked improvement can be achieved. So DMADV can also be used when there is existing products and process already, but a large improvement has to be done or completely a new design has to be done. So DMADV can also be used when there is already existing product, business or system, but we want to make a big change or a complete change in the existing business or services, because in these kinds of business or services, using the improvement philosophies like DMAIC and other tools like Kaizen may fail. So for this purpose, DMADV is used here. Now let us understand the differences between DMADV and DMAIC with the different simulated case studies. Here is a case 1 in which the conventional shoe manufacturing industry wants to develop a production line for the athletic shoes. The manufacturing process of the sports shoe is advanced and it requires more an advanced step of manufacturing. Which improvement methodology will you suggest? So basically here what is happening is the shoe manufacturing company was producing the conventional shoes only, and now it wants to go on a more advanced level with a completely advanced level of manufacturing. So what do we think? Should we go for the DMAIC approach or the DMADV approach? I will leave this one to you. You can leave your votes with the reason why you support it for DMAIC or DMADV in our Facebook poll. Now let us see the second case. Here the case 2 says a hotel chain named Gurkharaks wants to make an improvement in its customer acquisition and retention. However, it didn't show marked improvement with the previous improvement methods, as it seemed to go with the better and large number of changes in its process and management system. Which of the improvement methodologies will you suggest? We are given here that there are large number of changes in the process and the management system. The third case is a pharmaceutical company wants to improve the yield of the certain product. It wants to identify the source of waste and variation, minimize it and sustain the improvements. Which of the following improvement methodologies will you use? Now this question seems good to go with the DMAIC cycle. Why? Because they simply want to improve the system. They want to identify the source and waste of variation. We define some source of waste and variation in the define phase itself in the problem statement, and then next we try to analyze the real sources of the problem through the root cause analysis in the analyze section. We try to minimize it in the improve section and sustain the improvements in the control section. So in this particular case, we are good to go with the DMAIC cycle. DMAIC and DMADV cycle seems a lot confusing for many students. If you still get confused between the DMAIC and DMADV, you can raise your particular question in the Q&A section, or you can even raise your question or participate in the Facebook poll for the earlier case study in our Facebook page. Both DMAIC and DMADV have this phase as a common phase. Let us now study what do we actually explore in the define phase. As we already know, define phase is the first phase of DMAIC and DMADV cycle. We explore the following points in the define phase. We explore risk of undertaking and not undertaking the project. That means we first try to find out why we should undertake or why we should not select any project. We generally do project prioritization matrix or project risk analysis, etc. We also explore the needs of the customers. We learn the voice of customers. We also use various tools such as Kano model in this phase. We also explore the financial needs and advantages of the project, and we learn to form and manage the team. This team will be working on the Six Sigma project. Define phase also outlines the team focus, which we do through the stakeholder analysis. We communicate the findings with the stakeholder analysis, and we allocate different members to the different tasks of the projects through different tools such as RSCI matrix, etc. And this is also the phase where we launch the project. And at last, after the Six Sigma define phase is over, we draft the project charter and we communicate the findings with the other stakeholders. Now these are just the points from the surface. Let us study each steps of the define phase and the tools we use in each of these phases. But before that, let's learn why is it actually called the define phase, or what do we define? We call this phase a define phase because we define everything needed for the Six Sigma projects in the define phase. First, we define what projects need to be improved. We are defining the project needs that should be improved. And the tools used in this step of the define phase are project prioritization matrix. We prioritize what project needs to be selected. Before that, we should understand if we should select the Six Sigma project or not. Selecting Six Sigma projects is beneficial for improvement for any organization and any functions, but sometimes there might be simple solutions to the problem. So if those solutions can be fixed as soon as possible, or there is a simpler solution, we should use that solution. In fact, we cannot develop a Six Sigma project for every improvement. Note that Six Sigma projects take time, team, resources. Also, there are some financial aspects. So before implementing any Six Sigma projects, we should identify its need for the particular project. We'll further study about this in detail in separate lecture in this course. And another, this is a project prioritization matrix where we try to prioritize and find out which projects should we select. For example, in this scenario, we are prioritizing two projects, project 1 and project 2, based on different factors: duration, cost, complexity, return on investment, difficulty, and the available resources. And we are assigning different weight to the different projects and their factors. And based on the total weight at the end, we are trying to prioritize the project. So project prioritization matrix helps us to know which project is to be selected based on different factors such as duration, cost, complexity, return on investment, difficulty, and the available resources. In fact, there may be more or different factors than what I presented it here. We will study the project prioritization matrix along with the Excel sheets and templates in the Six Sigma course later. So the second phase or the second step of the define phase is we define the existing problem that we want to improve. There should be particular problem that we are interested in improving with the help of define phase. So what is that particular problem? In order to identify that, we use different tools such as problem statement, business case, is or is not analysis, and SMART goals. Actually, we use is and is not analysis more on the A3 analysis that we will study in the Lean Six Sigma belt portion. A problem statement can be formed by answering different WH questions: what, where, when, why, and who, and how the problems affects the business. Third, we try to find out the risks and rewards of the project. And for that, we use tools such as project risk analysis or the project risk assessment. We try to find out the risk inherent in project by different points, such as who are the project members, who is the project leader, what is the nature of the project, and scopes and benefits of the projects. And there may be other points also which helps us to assess the risk inherent in the project. So this phase or this step helps us to identify different risks present in the project, and based on those we brainstorm which project is to be selected and how the project is to be developed. The next thing that we study in the define phase is we define the current process. So what is meant by that? By the term or by the step defining current process means we identify how the current process is running. We identify the steps of the current process. We try to identify the layout. We try to identify the flow of the process, etc. The tools used in this process or in this step is the SIPOC matrix or SIPOC diagram, which stands for suppliers, inputs, process, outputs, and customers, process maps, and particularly value stream maps and the deployment maps. This is SIPOC, which stands for supply, input, process, output, and customers. The process steps is actually adding the value, and there are feedbacks. When there is any feedback from the process, it supplies the feedback to the suppliers, which receives the feedback and provides the input according to the feedback. And also there is a feedback loop from the customer's side also. The customers gives the feedback by the help of which we can make improvement in the process itself. Next, we'll study the value stream map also. Value stream map looks something like this. This though looks complex. In this instance is not complex at all. We'll study about different terms such as cycle time, lead time, value added time, non-value added time, etc. And there are different symbols such as Kanban symbols, information flow symbols, process flow symbols, etc. This is just to show you how a full-fledged value stream maps looks like. But I want to clarify here that one benefit of value stream map is identifying the source of the problem visually and also mentioning what improvement has to be done in order to eliminate the defect or loss at that particular point. For example, here we are using different improvement tools like Andon, SMED, Pokoyoke, etc., which are given in the yellow color. These all are the lean terms that we will be learning in the lean section. So actually by selecting this course, you are going to learn about both the lean tools and the Six Sigma tools, which is great for improving any Six Sigma projects because it will take care of the financial side also and also reducing the waste along with the improvement of the project. The fifth step is we define the customer's preferences. We try to find out what the customers really want, and we use different tools such as brainstorming for finding out what the customers really want, affinity diagram, voice of customers using the Kano model, and other tools such as house of quality. So this is an example of the affinity diagram where we group the items that are related to each other at the one side. Affinity means belongingness or closeness or similarity, etc. So based on the similarity, we group the brainstorm idea under one column. This is an example of the Kano model which is used in the voice of customers. That means we try to fulfill the customer's expectation based on their needs. There may be different needs of the customers which may be one-dimensional, attractive needs, or must-be needs, or reverse needs, etc. So the whole motto behind the voice of customers using the Kano model is addressing the customer's needs or preferences correctly. We'll study about the Kano model in depth in this define section. This is an example of the house of quality, which gives us various information regarding the relationship between the customer's desire and the features of the work or the engineering features. We can also compare our standing or our product's standing compared with the other competitors in the market. And this is a great tool in order to identify which engineering features or what features of the products or services can we improve based on the customer's demand or desires. We then define the team and responsibilities. For that, we allocate different people in the Six Sigma team, and these includes different belt professionals. We also provide them different job description, and we allocate the tasks with the help of RACI diagram. There may be many people with different work experiences involved in the Six Sigma team. These may be the white belt, yellow belt, green belt, black belt, or champion. And we allocate different tasks to these people along with other people which are also called the Six Sigma associates or executives who are not really related to the Six Sigma belts or who really don't have the professional Six Sigma belts training, but they can help during the Six Sigma project. So all these stakeholders are actually forming the Six Sigma team. Then this is an example of the RACI matrix. RACI means responsible, accountable, consulted, and informed. So through this matrix, we try to find out who is actually responsible for the project, who is accountable, who can be consulted, and who can be informed. So there are different priorities and job descriptions allocated to the different people involved in the project. With the help of this matrix, we can allocate different works to the people We then define the resources and financial figures. Of course, this is a very important step. We try to find out what resources we need and what will be the cost of the company and what will be the cost of implementing and not implementing the Six Sigma project, because finally, if the Six Sigma project is not going to help in the financial improvement of the company, although it always does, there will be no use of implementing the Six Sigma. So we try to find out what is the financial improvement or what are the resources that are needed for the implementation of the Six Sigma project. And this one is particularly more important when we want to communicate the project objectives or the project benefits with the owners of the company, because these are the business people and they look the financial aspects of the project. We then start the project and we communicate different ideas. We communicate about the findings of the project. We use various tools such as A3 analysis documents, stakeholder analysis, and the project charter. Project charter is an important document that is used in any Six Sigma projects and Lean Six Sigma projects. We enter every findings of the Six Sigma project inside the project charter. Project charter is the summarized document of all the Six Sigma process steps and improvements. This is an example of the A3 analysis report. Here we see different aspects such as background screening and problem clarification, current condition screening or breaking down of the problem, setting the target, analysis of the root causes, developing different countermeasures in order to counter the defects, implementing the countermeasures, monitoring results and processes, and standardizing the results. So the A3 document, particularly which we use in the Lean Six Sigma define phase, is also the document that we can use to communicate as a summarized version of the work in the Six Sigma project. Basically, after you complete the define phase, you will be able to fill up the two blocks of this A3 analysis project, that is background screening and problem clarifications, which contains the background such as problem statement, problem clarification and potential benefits, and also the current condition screening, which contains the process maps or the current process maps and also the SIPOC diagram. We have to do the stakeholder analysis before communicating any findings. Stakeholder analysis is a tool which we can use in order to find what actions are necessary based on the attitude and activity of the stakeholders. We can either manage the stakeholders closely, keep them satisfied, or keep them informed, or just monitor them based on their attitude towards the project and their support or activity. Now let's learn about the measure phase. Measure phase is the second phase of the Six Sigma and the Lean Six Sigma DMAIC and DMADV cycle. So in both DMAIC and DMADV, we have to go through or we have to follow the measure phase. So why it is actually called the measure phase and what do we measure? We call it measure phase because we measure everything needed for Six Sigma projects in the measure phase. And that everything that I am mentioning here can be anything related to Six Sigma, such as current project performance or the current performance of the company or any project in particular, all the current matrices, current sigma value, and how the process is operating at the present time. So in this phase, we quantify the extent of the present problem. We define what is the problem in the define phase, and then we quantify that problem, or we quantify how much problem is present. We quantify the extent of problem in the measure phase. But before that, let us understand what is measure. Measure is any value which can be quantified or counted. So in the measure phase, you should have something that can be counted. You cannot just record abstract things in the measure phase. And the process is called measurement, the process of counting. So what do we measure? It depends upon the type of organization and the type of project that we are practicing the Six Sigma or the Lean Six Sigma project. If it is an industrial project or if it's the industrial or manufacturing operation, we measure the cycle time, weight, purity, yield, waste, etc. If it is a healthcare business, we measure the inpatient number, outpatient number, number of returning visits, etc. It could be anything related to the healthcare business. If it is banking business, we measure loans, bad checks, debts, number of account openings, etc. And if it is any service or hospitality based business, we can measure the customer's compliance, which is related to the sales. We also can measure the returning customers and number of complaints, etc. So what we measure in the measure phase depends upon the type of project that we are undertaking or type of the industry. The first phase of the measure phase is developing a suitable data collection and the sampling plan. The tools that we use particularly in this phase is data collection form, sampling form, and the check sheets. So this is the phase where we sample the data. If the data is used in number, of course we have to sample, and we form the data collection plan. That means how we will collect the data. I've taken this screenshot from the Minitab. We'll be learning different aspects and calculation of the measure and analyze phase with the help of Minitab in this course. So for that, we have to know about what is data. There are two types of data. Continuous data, for example, weight, height, etc., which can be continuously measured, and count or summary data, which cannot be expressed in the decimal values. For example, if you are counting between defects and non-defects, that is called categorical or the count data. Suppose you are sampling 100 items and you found 4 number of defects, then 4 is the count data. You cannot just say 4.1 defects. And based on the continuous and count data, there are different types of graphs and summary statistics that we can draw, and it depends upon our objective. If we want to show the distribution of the data, we show the histogram. If we want to show the spread of data, we draw the box plot. If we want to show each individual data point, you have to draw the individual value plot. And if you want to identify the most common defect or those 20% of the causes that are responsible for the 80% of the errors or defects, we draw the Pareto chart. And just for the sake of comparing and based on display, we can draw the bar chart and pie chart also. We'll again talk about this later. So we talked that one of the tools used in the measure phase is the data collection plan. So what are the things that we cover in the data collection plan? We can cover who will collect the data, where, when, what, how, what, and who is responsible for the data collection. So it's basically a combination of the answers of the WH words. But before data collection, we have to sample. Now what is sample and what's population? Population is distribution of all the data. Suppose if you have 12 kids in your class, that's your population. And if you randomly sample, or if you sample them by any means, if you choose 4 individuals randomly or by any sampling plan, then we call them sample. Sample should be able to speak about the whole population, so we should try our best to make the sample data as homogeneous and as representative of the population data as possible. Now sampling can be probability sampling and non-probability sampling. There are different kinds of probability sampling. This is the example of systematic sampling, and there could be convenience sampling. I will explain in depth about all the types of probability and non-probability sampling in detail in the measure phase. So you don't have to worry about this now. This is just for the introduction. To collect the data and to represent data in different form, you can form the check sheets. There are different types of the check sheets and checklists. This is an example of the check sheets where you can also draw the tally marks. Similarly, you can make the checklist. You can make it more visually appealing with different kinds of checklists. So it all depends upon you and your project. The second step is we then draw the detailed process analysis. We also studied about the process analysis or understanding the current situation or current flow of the process in the define phase also. In define phase, we use process map in order to define how the current process looks like. In the measure phase, we use the process maps in order to identify how the process is running. So here is an example of the spaghetti diagram. There are random lines or zigzag lines, a person moving from different corners from A to B, then B to C, then C to E, etc. So this diagram shows the flow of the process. And also we use this kind of spaghetti diagram in the measure phase. Similarly, we can use different forms of value stream mapping in order to show the flow. The third step of the measure phase is validating the measurement system. We generally use tools measurement system analysis and gauge R&R or gauge reproducibility and repeatability for this purpose. MSA or measurement system analysis is the method of knowing or determining the range of variation that exists in a measurement system. And gauge R&R stands for repeatability and reproducibility. Gauge means instrument. So we are measuring the repeatability and reproducibility of the experiment with the help of gauge R&R to try to find out if there is any defect in the measuring device itself. I will show you performing the measurement system analysis or performing the gauge R&R in detail with the help of Minitab. So these are just some of the clips that I have taken from those lectures. We'll study those in detail in the respective classes. Similarly, we then collect the baseline data and display and organize those collected data so that we can see different patterns or relationship between the data. And the tools we use are, there may be different tools: histogram, box plot, dot plot, Pareto, IUP chart. Actually, there are many kinds of control charts. These are just some of the control charts. We'll be learning basically all types of control chart in this course. So this course will be very descriptive. We'll also be learning about the scatter plots, manifest plots, and the interaction plots. So we use different kinds of plots after measuring the baseline data, and we represent it in the graphical form based on our objective. If our objective is simply graphing the distribution data, we go over the histogram, box plot, individual plot, Pareto chart, bar chart, etc. And if your objective is finding the graph variables over time, we go for different types of control charts. Control chart is more important and you have to use them in every Six Sigma projects. I request you to do that, because measure phase is where you measure initially what's our baseline data, how is our current process monitoring, so that after we have made some improvements, we can compare that data or that chart with the final improved process. So if you have not any baseline data, if you have not any data of the current process, you will not be able to compare or understand or say validate that you have really made an improvement through the Six Sigma projects. So that is why the role of measuring the baseline data comes into play. And similarly, if we want to graph a relationship between different variables, you can draw different sorts of graphs such as scatter plots and manifest plots and interaction plots. We will study about the manifest plots and interaction plots not in the measure phase but in the improve phase, when we are studying about the design of experiments. You have to design the experiment, and this will help you to optimize your process in order to improve the process. So basically, I'll be using the manifest plots and the interaction plots in the design of experiment, not in the measure phase. Now, after plotting those data and after recording all the baseline data, we try to find out important parameters like current sigma level, DPO or defects per opportunity, DPU, defects per unit, DPMO, defects per million opportunities, RTU or roll throughput unit, etc. in the final phase. Now this is important because it also helps to find out the current matrices. How is our process or performance doing currently, so that after improvement we can see if our sigma level has improved or if our DPO or DPU or DPMO or RTU have actually improved. So we should try to find out these parameters. Now I'll be using this table a lot of times in this course because this table is very important. Suppose before implementing the Six Sigma level, you found that your DPMO was, or defects per million opportunity was 45,500, which improved to 0.02 defects per million opportunities after implementing the Six Sigma. We have to calculate these matrices, DPO, DPU, DPMO, etc., or we have to calculate what's their current sigma level, so that these comparison can help us to conclude that we have really made improvement through the Six Sigma process. We then finally update the project charter. We learn in the define phase that it is the summarized form of all the activities that we enter in the Six Sigma project. We enter different business case, we define the opportunities, we define the threats, we define the cost, and we define the project deliverables, etc. And after the measure phase, we can update the project charter, like we took these parameters for the measurement and the current Six Sigma level was this, or current the defects per million opportunities was this, so that later after the control phase we can again enter the controlled sigma and DPMO value or different improved matrices, and we can compare between those two values. So finally we conclude the Six Sigma or Lean Six Sigma measure phase with the project charter. How are you finding the course? I genuinely want you to learn valuable things and really implement Six Sigma in your project. I want whatever you learned in this course to be practical. So if there is any confusion, I request you to join the student support group if that's more feasible for you. We can communicate either way. The analyze phase is the common phase that is to be practiced in both DMAIC and DMADV cycle. That means we have to analyze for the situation of the existing problem and the root causes of the existing problem in both the DMAIC and DMADV cycle. Now let us start with the question itself. Why is it actually called the analyze phase? So what do we analyze? This is called analyze phase because we are basically trying to analyze the probable causes of the problem and we are trying to find out the root causes. So can we directly jump to the analyze phase? That means without doing the or without performing the task in the define and the measure phase? No, because we need the data gathered from the define and measure phase to work in the analyze phase. And you know well that Six Sigma is a statistical improvement process. That means everything that we do in Six Sigma requires data. The data should be measured and then they should be analyzed, and the analyzed data are used for the improvement of the process and subsequently control of the process. That means control of the improved process. So are we done after we find out the causes of the problem? We hear it quite often that analyze phase is related to the root cause analysis. No, because we need to validate that these causes are significantly important to gain attention. During the brainstorming session, we may find that there are different causes responsible for the effect. That means there may be different causes that may be responsible for the problem. But we need to validate that these causes are significant to gain attention, because solving any problem requires time, manpower, money, resources, etc. So only those causes that probe the significant effect on the effect should be given the priority. So we should validate those causes only. And if we have enough time and resources to solve every problem, or say to solve every causes of the problem, that will be more better. But the causes or the problem which are most significant are the ones which are responsible for most of the waste and defects in the Six Sigma project. Why is it necessary to perform the analyze phase or to go through the analyze phase? Because we have to analyze the pain points of the process. So analyze phase basically looks at the pain points. That means those points which are responsible for the defects or which are responsible for any non-value added steps if we are talking about the lean process. So what are the steps of the analyze phase? The first step is examining the process closely. By examining the process closely, I mean we should have a sound knowledge of how the process is actually working on the production level or on the service level. So we should be sound about the knowledge, or we should have a clear picture in our mind and documented evidences that the project or the process is running in that particular way. Different tools are used in this step. The first is Gemba work, time analysis, value added analysis, and value stream mapping. So what is Gemba work? Gemba work is the term used to describe the personal observation of the work where the work is happening, and this is also called the process walk. Gemba is a Japanese term, also called the Genba, 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 and it's used for observing the actual working of the process or working inside the plant floor. Similarly, time analysis is also done in this first phase or first step of the analyze phase. With the time analysis, we should know how much time is spent in each process. We should study about the delays particularly, because delays are also one of the 8 forms of the waste of the lean. We already learned that in the 8 forms of waste in the define phase. So delays are the result of the waste of time. And with the time analysis, we know exactly in which part of the process the time is exactly wasted. So that process is non-value adding, because it is not adding value to the process, but simply there is the waste of time. Now there is a value added analysis. Value added analysis are those activities which the customers are willing to pay. So these are those activities which are quite beneficial to the customers and which the customers want to see in the product or processes. They simply add value to the product and processes. And non-value added activities are those activities for which the customers are not willing to pay, and these do not directly add the value to the product or services. Typically 70% of the total lead time is wasted in non-value adding activities, and it is where the role of Lean Six Sigma comes into play, because its job is to particularly identify those non-value added activities which simply extends the lead time. And what is lead time? We already learned that lead time is the duration when the customers first order for any product or services and when the customers receive that product or services. So the entire journey or the entire length of the time is the lead time. So 70% of the time is generally non-value adding time, and our job is to reduce that non-value adding activities which can help us to reduce the waste of time. Now these non-value added activities can be either minimized or eliminated. In some instances, it is not quite possible to completely eliminate the non-value added activities. For example, transportation is one of the non-value added activities. We need some time for transport as well, and it takes time. So though being non-value added activity, we cannot completely eliminate them. We can reduce the non-value adding activity with the help of Six Sigma and Lean. So what are the steps of the analyze phase? Now this particular step is performing the graphical, statistical or process map analysis. This is the step where we actually do the analysis part. Different kinds of analysis are performed in the analyze phase, first being the graphical analysis, statistical analysis, and the process map analysis. We use different tools such as histogram, box plot, Pareto, correlation, multivariate diagram, interaction, and the main effect plots for the graphical analysis. Similarly, we can use the regression test or the hypothesis test for the statistical analysis, and we can use the flowchart and process map for the process map analysis. Then we look for what are the causes of the problem. So this is where we practice the root cause analysis. There are many root cause analysis tools such as Fishbone diagram, cause and effect diagram, 5 whys, fault tree analysis, is and is not analysis, tree diagram, etc. And there are many more. We then verify the causes of the problem. Now verification of the causes of the problem can be done with the help of hypothesis test. Hypothesis test is where we hypothesize certain statement and we try to find out whether the statement is statistically significant with the help of null and alternative hypothesis. This is a chart which you can use in order to identify which hypothesis test to use. For example, different kinds of hypothesis tests should be used for non-normal data, for the discrete data, or for the continuous data, or for the normal data. So you cannot just use any type of hypothesis test for any kind of data. I will also provide this chart in the relevant section in the hypothesis test. This is an example of 5 why analysis where we try to repeat the question why for 5 or more times to come to the root cause of the problem. This is an example of is and is not analysis that we will also study in the analyze phase. Generally, is and is not analysis is also used in the define phase to define what is the scope of the Six Sigma project that we are going to perform and what are not the scope of the Six Sigma project. But here particularly we are trying to find out the problem or the causes of the problem with the help of is and is not analysis. Similarly, there is also a fault tree analysis. This is an example of the fault tree analysis where we are trying to find out the causes of the employee turnover. We'll also study the fault tree analysis in detail and in depth in this course. Similarly, there are different kinds of cause and effect diagram. I'm sorry that the screen got little dim here. This is a cause and effect analysis or fishbone diagram. This is a 4S fishbone diagram, and these are the 6M and 8P fishbone diagram. Fishbone diagram are the graphical or visual representation of the causes and sub causes of any problem or effect. Then we finally update the project charter at the end of the analyze phase. At the end of define phase, we have a long section of the project charter where we learn that we should write the overall plan of the process. So if we write this was the overall plan, we should also add a column where we should write this was the actual time plan and this is the actual time where the analyze phase is completed. Similarly, during analysis, different kinds of costs and resources may be utilized. So we also have to update the project charter about these costs and utilities. So with this all, we complete the analyze phase. So this is just a brief explanation or the description of the activities that we perform in the Six Sigma analyze phase, which we will learn in more depth and in detail. So thank you all. Now we are going to learn about the improve phase of the DMAIC cycle. We know that Six Sigma operates on two improvement cycles, DMAIC and DMADV, for different purposes. So improve phase is the fourth phase of the Six Sigma DMAIC cycle. So why it is actually called the improve phase? It is called the improve phase because we try to find the solutions to the inherent problem and we try to improve the performance of the project and we try to eliminate or reduce the root causes of the problem in the improve phase. And with all these actions, we actually improve the current scenario of the process or the project or any problem that we are investigating. So how do we carry out the improve phase? There are different steps as there were in the define, measure and analyze phase. First of all, the first step is we gather all the idea to solve the existing problem. And this is the phase where we reach out to all the associated stakeholders in order to find or pull the improvement ideas that is required for the improvement of the process after analyzing what the problem is really about or where the problem really stands after implementing various analytical tools in the analyze phase. So we gather ideas to solve the existing problem with the help of various tools such as the lean improvement tools. We'll basically learn it in the lean Six Sigma improve phase. We also use the brainstorming and benchmarking tools. There are various kinds of lean improvement tools that we can use in the improve phase. For example, if it is the case of manufacturing industry, we can use the lean tools such as single minute exchange of dice, Kaizen, Kanban, Heijanka, Pull and Jidoka. Single minute exchange of dice is a lean process where we try to reduce the changeover process to 9 minutes or less. Kaizen is a continuous improvement philosophy. Kanban uses boards and cards in order to show the flow of the process. Heijanka helps in the leveling of the process. That means it helps us to allocate the required volume of job or the required stress to the required processes. Pull system is based on the principle of producing any products or services only under the demand of the customers. And we can use the Jidoka, which also means the automation. Simply, if it is a healthcare related business, we can also use different lean tools such as value stream mapping. Value stream mapping is a process mapping tool where we see the flow of the value on different steps of the process. Kaizen is a continuous improvement tool which is similar to what we use in the manufacturing business. If it is a banking related or financial business, we can use the lean improvement tools such as Kaizen, and we can also improve the value stream. We can use different sorts of value stream maps. And if it is any service or business related function, we can use different lean improvement tools such as Little's Law, and also as before we can improve the value stream. So different kinds of lean improvement tools can be used for the different kinds of services or different kinds of business. So we use different kinds of lean tools based on which business or services we are really interested to improve. So what is brainstorming? We already learned that brainstorming is the process of the idea generation. Here we try to generate different raw ideas with the help of discussion or with the help of votings and opinions. After brainstorming, we can use the affinity map or affinity diagram. Note that these tools were also used in the Lean Six Sigma define phase. This is a affinity diagram where we gather the related items under the common heading. Here the unorganized ideas are put into the single group. We can also use the benchmarking tool in this step. So what is benchmarking? Benchmarking means the quality by comparison for achieving better results. Now many people understand benchmarking as a process of stealing the ideas from a big or a good company, but that is not true at all, because benchmarking for sure looks what idea or which process is working best in the market, but we have to tweak the ideas or we have to change that improved idea to our own processes in a suitable way so that it suits our process perfectly. So benchmarking is also one of the lean tools that we use in this step. The second stage is selecting the practical solution out of all the brainstorm solutions. So earlier in the step 1, we were trying to search for the solution of the problem, and then we funnel down the practical solutions out of these brainstorm solutions in this stage. We can use different approaches for this purpose. We can use the weighted matrix, impact effort matrix, decision matrix, which is also called the PUG matrix, and sometimes we can also use the different root cause analysis tools. We already learned about different root cause analysis tools in the analyze phase of the Six Sigma. This is an example of the impact effort matrix, where the impact of the proposed solution is drawn on the y-axis and the effort required to implement the solution is drawn on the x-axis. So we can see here that there are different impacts ranging from low impact to high impact, and different efforts required ranging from low effort to high effort. And there are different priorities. So if impact is high, even when we can put the low effort, we should give the first priority to that effort. Similarly, if the impact is high, we also need to put the higher effort, then we should go for the second priority. Those would be the major projects. And similarly, based on the impact and effort, we can select between the first, second, third, and the last priority. The second one is the weighted matrix. This is just an example of the weighted matrix. We give certain weight to different criteria that we are measuring. And suppose here the different suppliers are getting different weights. Supplier A is getting 2, supplier B is getting 1 for the quality, and so on. And we can sum down the product of weight and the point that different supplier gets and add that sum at the end. And that supplier which gets the highest total marks will be selected in this phase. We will study this in depth in the weighted matrix section, so I will not just explain more on this because we are going to repeat it again. This is an example of the modified weighted matrix. So we can also use this matrix in order to select between different solutions. Suppose if the solutions were selecting between supplier A, B, C, D, E, F, and Z, and so on, we can select which suppliers to choose based on this matrix. So how do you carry out the improve phase? What will be the third step? The third step is we will develop different processes and value stream maps with the improved solutions. For example, this is a value stream map where we are suggesting different suggestions. We are suggesting to look for 6 big losses in different process steps. We should look carefully for the 6 big losses in dispensing, sifting, granulation, lubrication, compression, coating, sorting, packing, and stripping. So these are the different approaches of the manufacture of the pill or medicine or a tablet. So we are suggesting if there is any one of the 6 big losses, we should look and revise this value stream so that we can reduce the defects. Similarly, in different steps in this value stream map, the yellow symbol suggests that we should implement the single minute exchange of dies in this particular processes. The value stream map is suggesting us that we should implement the single minute exchange of dies in the different processes such as granulation, compression, coating, and packing. Similarly here, many things are suggested. For example, it is suggesting us to improve the process with the identification of different process lags. We can use lean tools such as Washing Kanri, which is also called the policy deployment. We can use the e-Kanban. We can do the daily lean meeting and implement unknown in different steps of the production process. So these are different ways in which we can suggest for the improvement in the value stream map. Similarly, we can also suggest different forms of the improvement in the deployment or the swimlane maps. We then pilot test and refine the solution. So we can use different tools such as PDCA, force field analysis, and design of experiment for this purpose. PDCA helps you to make the improvement in any business and projects, and it operates on the continuous improvement cycle: plan, do, check, and act. We plan what improvement is to be made in the plan phase. In the do phase, we make the improvement. In the check phase, we check if our improvement, which we make on the small sample size or in the small particular department, is really going to make a viable profit or the viable advantage. And in act phase, if it is really making a progress, we inform the management and we implement the improved process in all the phases and all the works of the organization. Similarly, we also study the design of experiments in this phase. We studied the design of experiments in detail in the green belt and the black belt projects. So what is design of experiments? In design of experiments, we try to either screen different factors or we try to optimize the factors. So you may be confused about what is factors, what are levels, etc. I explained in detail about factors and level, but just for the understanding, suppose if you are not sure which of the 15 improvement tools that you selected are really efficient in making the overall improvement. So if you are not sure, you have to screen those factors. So for that, you have to go through this screening part where you plan the screening experiment and you create the screening design. And from those 6 to 15 factors, you select only those 2 to 5 factors that are really making some impactful result on the improvement, because you cannot select all the factors that makes the improvement, as it will increase the cost of the project. So you have to optimize those 2 to 5 factors that you have finally selected after screening the factors. And if you already have only 2 to 5 factors, we directly go through the optimization experiment. We try to optimize the experiment and see which factors should be selected, and we know exactly which factors should be adopted in what amount or what degree, so that it can bring about the meaningful improvement in the project. So after this design of experiment part, the next thing we do is simply we implement the solution. We use different checklists and plans for this purpose. For example, this is a checklist for the FMEA or failure mode effect analysis, where we try to execute or find the risk priority number. And if there is higher risk, which is shown by the risk priority number, then we will select that step to be improved first. So based on the severity, that means how severe the problem is. Based on the occurrence, that means how frequently it is occurring, the problem is occurring. And based on the detection, that means if it is easy or hard to detect the problem. Based on these factors, we calculate the risk priority number. Risk priority number is simply the multiplication of the severity, occurrence, and detection. We'll also study this in detail later. This is a checklist for the 5S. We form the checklist for sort, systematize, sign, standardize, and sustain. And we give different scores. And based on these scores, we get an idea which things are need to be improved. The next step is we validate the improvements. There are different tools such as measuring the baseline data, simulation tools like the Monte Carlo simulation. So we should not hurry at this stage, because we have to wait and see whether our proposed improved solution is really going to make any profitable outcome. So we have to gather all the data, and we have to again see or analyze in this section also whether our improved solution is really going to make any difference. We then finally update the project charter. The tool uses project charter, so we can update different steps of the project charter, such as when did our improve phase started and ended, what were the cost and resources associated with the improvement phase, etc. And finally, after filling up this improved phase project charter, we complete the improved phase. Now finally, we have reached the final phase of the DMAIC cycle, that is, we have reached the control phase. And in this phase, we will study how controls are established so that our improvements or gains are sustainable. So it is actually called the control phase because in this particular phase, various kinds of control devices, that may be lean devices, or that may be change in the management, or that may be the change in a procedure, or any standardization practices that helps to ensure that our improvements or gains are sustainable. So how do we carry out the control phase? Let's study the steps. The first step is we develop the standards and find the process capability, sigma level, and other calculations. We also establish the sigma levels, DPO, DPMO, and other parameters. Finally, in the control phase, we should specify that we should be running in the particular sigma level, or we should specify that our DPMO or the yield level should be between this and this range. In the improve phase, what we did was we tried to see whether we have made the improvements by using these parameters. That means by using the sigma level. We compared the sigma level, we compared the DPMO or DPO, etc. We try to observe whether we have made any improvements compared to the measured phase value. And in the control phase, we specify that in the future our specifications is this, or say we should be running in the particular type of specification. The second step is we make sure that our new process is well under our control. Now how to do that? For that, we use various tools such as monitoring and response plan, control plan and control charts, etc. This is a monitoring plan where we monitor different activities, where we monitor the inputs, process and outputs. We write everything such as targets and how we collect the data, how frequently we are checking, and whom the job is assigned, etc. And in the response plan, if there is anything that is to be acted upon, we write at what point should we try to improve the process, who should respond, how should our reaction plan be like if anything wrong happens with the system. So we also make the response plan along with the monitoring plan. And there is a control plan template also. I'll be providing this template in the particular section. In the control plan, we write what are the parameters in your process that is to be controlled, what is to be measured, what sample size is to be taken to be measured, how should be the specification. The specification talks about both lower specification and higher specification, and the control plan also says what to do if our specification is below or upper than the normal, and how to act, who will act, and who will authorize, etc. So the control plan is basically a tabulated form of our plan to control the process. And as I said before, we try to run various types of charts. We try to visually observe whether we have made any types of improvement in the improve phase. Now in this phase, what we do is we set the specification of the lower and the upper point. That means in this particular phase, we set the upper control limit and the lower control limit. So after we set the upper and lower control limit in this phase, if any deviation occurs, that should be wrote as a trigger point. For example, if our upper specification limit is 10 defects per hour, then if our production process runs and if we find that our process has higher defects or the process yield has higher defects than the 10 number of parts, then the trigger point is 10. And in the response plan, we have to write we will respond to that deviation, and we write how will we respond to that deviation in the reaction plan. So all these charts, the monitoring plan, response plan, and the control plan work side by side along with the control charts. Now after that, we have to document the improved process. So there are various ways to document the process. We already learned about A3 document or the A3 analysis. We already learned about the project charter, and there are other documents as well, such as specifications or standard operating procedure, where we can document the specification of running the process or the way to run the process in this particular phase. So we work with various types of documents such as standard operating procedures, standard work charts, visual displays and controls, 5S checklists, or any form of document that helps us to know the control limits or that helps us to set the control points of the process. Now these are the kinds of the visual displays. Different kinds of visual displays are available for different purposes. For example, on the upper left hand side, we see the visual displays of the white pictures in the red background, which stands for anything related to fire hazards. Similarly, there are other kinds of visual displays as well. So one of the important benefits of using the visual displays is we can let the employees or any other people, or we can warn or we can show them any kinds of cautions in the process easily, because pictorial form of message is more suitable to the eye. Our eye catches it fast. I saw many kinds of visual displays when I worked in the factory premises in Japan, and they have almost every kinds of visual displays for almost every processes. They have visual displays in the stairs, they have visual displays on the elevator, escalator, visual displays on the road, visual displays on the sidewalk, and almost everywhere. And this helped particularly to me in the beginning when I did not know the Japanese language properly. So one of the important benefits of visual displays is you don't have to worry about the language because it is a pictorial representation. Now these are the points to be considered while performing the 5S. I will be providing you this particular template in the relevant lecture where we have established different points for different processes of the 5S: separate, or sort, strengthen, sign, standardize, and sustain. So we can give our points based on these criteria described here. So it also helps us to control our process. So this gives us the criteria to control our process with the help of 5S. We can also use other forms of the standardized documents such as standard work chart, which shows us how should be the process be moving, where there should be the quality, safety, and standard work in progress, how should be the movement, etc. I'll also be describing this in the relevant section. Another is standard production capacity sheet. This is particularly more important and useful in the production premises, although we can change the header topics for service-based businesses too. So here we can write the total operation time of the man and machine, total time for the tool changes, and whether we are taking longer or shorter time than what is the time specified. We'll be learning the standard production capacity sheet in detail in the control phase. Now the next step is we have to train the staffs about the new control limits and changes in the process. So in the control phase, we establish the controls, we establish the specifications, we establish the flow of process, or we establish this is how the process should be working and within these limits. But we have to make sure that every employee is trained about the new control limits, because if not, they will be starting to work under the older process parameters, and if they do so, it will not be fruitful. Our whole Six Sigma project is aimed at making some improvements, so in order to make it fruitful, we have to train the team. Now to do this, we can form different cross training chart. We will be studying how to perform the cross training chart in detail in this section. There could be different person allocated for the different roles, and with the help of this cross training chart, we know exactly what the particular person is more trained in, or in which field he should get the training. For example, David is good in marketing because he doesn't have to go for any assisted operation. He can go on his own. He will not have to be get assisted by anybody. He is a good in sales because he is a trainer in sales, so he is quite good in sales and marketing, but it shows that he is not quite good in the distribution process because part that is said it belongs to the untrained person. So this is how we can draw the cross training chart. As I already said, we'll study this one in depth in the section. Next, we finally update the project charter and other documents such as A3 templates. The tools used are project charter and the A3 template. This is an example of the A3 template, and by the end of the control phase, we have to make sure that we have filled all the important section or all the sections of the A3 document. Similarly, the control phase is also the phase where we have to sign off and close, and for that we fill off this sign off phase. We fill off who prepared, who analyzed, and who validated the different steps at the end of the control phase with the signature and date of the project leader and project champion. So this is how we end the Six Sigma project. Thank you so much.